Yeah, because this is I almost was looking at all this and was like, oh, this is right here is a function. No, it's not. This is just a um. Okay, sure, yeah. So we'll do that, and then we're gonna change that to like AG for adapter graphics. Um. Um. I'm gonna, you know what? I'm gonna do this. Um. Um. C constant like setup. Um, this code was moved from the ini initialize global. What the hell? God damn it. Um, hold on. Initialize global data. Yeah, ini global data. So I just want to make a note that this was removed. This was moved from the ini global data function because I thought the information here was too specific to belong in the global data section, right? So a lot of this is, a design choice, but just having a reason for like, we definitely want to identify this chunk of code as somehow logically separate from this part of the function. So I'm going to put it in there like that. So now I know we definitely have some issues we need to resolve. So adapter graphics is right there. And then we have these guys. So if we actually highlight these, when we scroll down, we should probably see the reference to them, and we should just need to refactor some of those references. We don't need to refactor those. Those are the shader code. But down here, so it's no longer global data dot that, right? Because now it's adapter graphics, and then this is ISO mem. And then we can make a little note. Data graphics dot ISO mem is equal to global data dot ISO mem, like that. And the idea is that we're gonna have it in the comments, but we can have fractionated comments like this where we refer to like these different ideas, but we want the code, the actual code, to be one cohesive narrative. So if we have like any uncohesive parts that we might want to keep track of, just to understand the evolution of the code, I'm gonna like keep little comments like that here to like help us. So this is the main memory, and it's going to be global data dot the main memory. And so this is just a little helper to help us keep track. So then we'll change things around, and then main memory, right? So the adapter graphics, the isolated memory, the main memory, and then the texture handle, which we get from creating a texture. And so same thing here, we got to comment that out as well. And I'll just put, right, and we can line it over this like that. To kind of, that way we have an idea of, oh, this probably used to be that, just to get an idea of where everything came from. And it'll also help us, like, if someone ever looks at this and is like, you know what, this would probably make sense if it was in some type of global container rather inside the class container, right? If somebody has that thought, they can look at this commented out code and be like, oh no, they already thought about this stuff being in the global data container, and for some reason they decided against it, right? Because if we don't record why we don't do something, what could happen is we didn't record why we didn't do it, so we move A to B, and then somebody comes along the code where the thing is in B, and we didn't record why we didn't put it in A, so they take it and they move B to A. Somebody else comes along the code, they see it in A, they don't see a reason for why it's not in B, because we didn't say why we didn't do it the other way, so they move A to B, and so on and so on and so on, and shit gets juggled around and juggled around and juggled around. So I think it's very important to state why you did not do something as well. So this is just a clue to be like, there were serious considerations made when we decided to put the stuff that we did into the adapter graphics. It wasn't like a frivolous decision. So that way, if somebody wants to so that's going to prevent people from frivolously moving things around. Because they're going to look at this and be like, oh, you know what, that was actually a pretty seriously well thought out decision. I don't think I should just move this around at a whim. And since this is my own code base and I'm talking about people, like on a team, when you want to think about dumbass people doing things to your code base, don't forget that that dumbass person can be you in the future, right? Future me could forget shit, so I need to like leave comments for future me, so future me doesn't sabotage present me, right? You know, don't, if you're gonna have that negative attitude of, you know, oh, people are gonna come around and screw up my shit, you should probably apply that negative attitude to yourself as well, because we're all human here, right? So to human is to err, to human is to fuck up, and we're all gonna fuck up, right? Okay, so I like that, and right, since we put this in this generalized container, and we know that we were using this generalized container down here, that refactor there should be pretty good. And then all we have to do is go way back up to this global stuff, and all of this global initialization stuff, we can totally just get rid of that. And this global data object just needs to be like an empty object now, because we don't have anything in it yet. So we're going to say var global data equals, and then there's nothing here yet. And we want to just comment it all out first and run it, and make sure that we didn't shoot ourselves in the foot anywhere. And then once we get the code back into our running state, then we can blast all of this away. But we don't want to delete it just yet, because we might need it for reference to figure out what we screwed up if I screwed up something and it doesn't run anymore, right? So we're gonna refresh, and it still works, and that actually bothers me, because we made so many changes that I'm like, I should have broken something. I've made less changes before and not had something break. So we're gonna inspect in the debugger and make sure that it's not like a... I want to make sure that it's working because it's actually working, and not just some type of like, did I miss something? Like, why is this working? You know, like, so I'm gonna highlight here, because that's kind of what I'm most concerned about. And I'm gonna inspect the adapter graphics. The context graphics is null, but if I step to the next, let me full screen this. If I step to the next statement, that should be populated. Okay, so context graphics is the WebGL2 rendering context, so that is nice. That's what I expected. Okay, we got our isolated memory. We got all those nice variables. We got our main memory. Oh, that looks beautiful. I'm satisfied. I think we actually managed to pull off that refactor relatively unscathed. So what we are going to do here, though, is in this global data here, we are going to use Hold on, you can't see. These 512s, the 512 and the 1024s here, need some place to live, like, and that's kind of the purpose of the global data, is to consolidate all those magic numbers that we're using for initialization things. So I'm going to say, like, we already have these pixel widths and these pixel heights. So if we, right, like, I don't want to fractionate our variables like this, you know, like, right, and then have this here, but then also have this here in our adapter. And so how could I do that? Well, one way we could do is we could have, like, we could call it initial, right? So we know that this is the value it starts at when we boot up, but we can't rely on it after we're done booting up, right? We could do something like that. Or we could do, so I do like that, so I'm gonna go initial, but I'm not gonna use pixel width and pix height. I'm gonna use the a span, because I expect these values to be identical when the code's running. So how do we categorize this? Well, we definitely see how we have these chunks like this. So it could be initial, and then isomem, and then pix span like that, and then initial main memory pixel span. And we notice that we have the different part, right, is like, you know, in the middle. Oh, control 0. The different part is kind of in the middle, and I don't really like that, because the idea is to have the differences at the end, right? So what we could do is initial well, let's say that this isn't a word that we're going to be using as much, so maybe we want to not use something completely shorthand. Initial, now we're just going to say initial initial span, and then like that, and then master memory. I don't know here. Or we could do initial, right, we can have like an initial container. So initial values. Initial / starting. So initial, aka starting values. Right, we could do something like that, and then we could just put like a in here, and then I'm gonna do something like this. I'm gonna do and then if we do that, the pixel span, and then the ISO memory, and then the span of the master memory, and then maybe a little comment that lets me know kind of like what I was thinking about calling it. And then we could say initial spans for texture memory. We could just say And we could have like something like this, like adapter, the graphics context dot isomem dot, and this is pix width or pix height, like that. It's kind of what we have going there. The adapter graphics dot the master memory, and then it's the pix width or the pix height is kind of what this is for, right? And this is how we wrote it, right? So if I go Control F on this, we're gonna find it, right? Yes, yes we are. Okay, so and okay, yeah. And then what we're going to do is we're just going to set these to, one is 512 and then one is 1024, right? 1024. Okay, so we have this global data object, and we seal it before we return it. So that looks good. Let's refresh, make sure we didn't screw anything up with any, like, kind of syntax errors. Okay, that looks good. And then all we're going to do is I'm going to take global data dot initial values. Hold on, sorry. We're going to take global data dot initial values dot the span of the ISO memory, and then the master memory as well. But I'm just going to take that one for reference, and then we're going to look for those 512s, right? Right. So, oh, am I going backwards? So we're going to look for those 512s where we're using them down in the code. So we're using them right here, hard-coded here, magic numbers. And now we can take that, and now we have this understanding where when we look at this, we kind of understand that the width and the height are supposed to be equal, right? So when I use the word span, what I mean is that span means, that's just my word for meaning width or height. It means that it's the dimensions of some type of two-dimensional object that must have identical width and height. So sometimes I don't like to have width and height variables, like duplicating this, because if it's always going to be square, why do I need to define width and height? So I use the word SAN to mean span, which means width and height are always equal. And then, we could make a little note here that this is 512, because it's probably not going to change. If it's probably not going to change, then why do we go through all that work? Yeah, I could be over-engineering this. And then we have less room for these notes here as well. Or we could take these notes and we could put them up. So we could put the notes above these things. So we could have, we could put the notes about what that's all about. So 1024, right, is 512 times 4. And then, so we don't need that like that. That's good enough. And I'm gonna can I indent one more level and get away with that? Now I'm just gonna section off these two variables within the object, so I can, so I know that when I glance at this quickly, I know that this is some type of logical section, and there's some type of strong relationship between these two variables. And then when I look at all these comments, I know that all these comments are somehow clustered and related because of this kind of divider that I've put here. So let's go back to where we were mucking around with our variables. And we're going to take this, and we know we need our 1024s, so we're just going to paste that there. Make sure everything lines up nicely. And then it's the span of the master memory this time. And we know that the master memory is the 1024. Okay, so now that we have that, if we refresh. It should not be broken. And that looks good. Let's check the debugger. Okay, so no problems in the debugger. So what else? So it's about time to stop this video. Is there anything else that needs to be done, or do we have this sufficiently cleaned up to where we can work on adding the texture sampling logic? And I think we're pretty close to adding the texture sampling logic to this code. So I think what I'm going to do is I'm going to take some of the new variable names I've made and I'm going to kind of like document them so I know about them in the future. I know what their strict definitions are. And after I've documented that, I will start showing you how to sample colors from a texture using a GLSL shader, right? So where are you? So this shader code, we're gonna like modify it so that it will sample from the textures. But for now, I need to just not clean up some stuff, but just document some of the new variables I created, and then I'll be back.